Okay, so here it is. I hope that you can see it and you can hear me right. So I would like to give you just a kind of generic overview where we are with the eScience Center and how we are implementing the first prototype of the eScience Center. So let me put this down and this one to the side. So yeah, okay. So again, welcome. I think you know me from the previous presentations now, so I will probably spare the introduction, and let me just straightforwardly go into this kind of overview of what was the progress regarding the implementation of the eScience Center. So this is more or less copied and pasted from the grant agreement. Obviously, we have a slightly different view since then, because when we've written the proposal was almost 2 years ago now, I believe. So things are changing. But I think as a kind of rule of thumb, this is still a good kind of starting point, what we would like to achieve with the eScience Center. So this is a central integration tool for data models and scientific services. So we would like to develop something where all these what we now call resources, data models, and scientific services can be accessed. It provides integration and more efficient utilization of currently existing heterogeneous and non-interoperable tools and services. So we would like to achieve some kind of central place, but also some kind of higher level integration of these tools and services. It is accessible through high-level graphical user interfaces, so a typical scientific user, a typical scientist can use it, and we try to avoid like command line interfaces or very low-level access point wherever it is possible. Also, we would like to support the learning process. So we would like to provide learning material, scientific material, publications, various tutorials, various information, how the whole thing can be handled, and what is the meaning of the actual information which is there. It will exploit cloud-based computation and data resources wherever it is appropriate, in order to make the whole thing scalable, in order to make it scale in case of large number of users and complex computations or large amounts of data. And the basic functionalities which we were originally thinking of in the proposal were registration and cleaning and processing of data sets, registration of models which are acting on these data sets, and utilizations of applications and workflows implementing the models. So these were, again, our original ideas. And you will see we are maybe diverted a little bit from this, because obviously we learned a lot during that time. But obviously, I think the kind of rule of thumb remains. So there is no major difference from what was written in the grant agreement. So let's see that what is the planned roadmap. And again, this is more or less based on the grant agreement, what we have for the eScience Center. So we had the deadline where the initial requirements of the eScience Center needed to be collected by the 30th of November. So this was a deadline which we achieved, and this is documented in D5.1. Which is called Collection of User Requirements and Analysis of the State-of-the-Art Technologies. Again, this is not a final set of requirements necessarily, and this is going to evolve, but this is our kind of initial and current understanding, which was documented by the 30th of November. Then we had a deadline about a proof of concept implementation, which is by the 31st of March. And again, this deadline is now coming up, and this is going to be implemented in or documented in D5.2. And this deploys some candidate tools to demonstrate how they are working in the EGI cloud. But this is not an eScience Center, because this is without any major integration of these tools. So we are not necessarily producing anything which is usable by the community. We are providing a proof of concept that we can put this together. And then the first release of the eScience Center will be due in a year's time, which will be a first prototype implementation and the documentation and the user feedback for that one, which is due for the 31st of March 2023. And then another release will be in a year's time, and the final release will come up in 2025. So in basically, this is the kind of planned roadmap. Every release will be documented in a deliverable, and every release will end up after 2023 in a kind of usable version of the Science Center by the community. So again, this is what was planned in the grant agreement. Now, where are we now? Initial requirements have been collected, as I said, and this was collected through questionnaires, and the feedback was already given to you in that January extra training workshop, which Anna mentioned. So we had a workshop in January where I explained the kind of outcomes of the requirements collection process, and where you have all learned what these initial requirements were or what the analysis of these requirements were. We also implemented a proof of concept where a model was executed on EGI cloud resources using some candidate technologies. I'm going to explain that in more detail in this presentation. We defined a generic set of services which will be supported by the eScience Center. So we kind of set down what will be the kind of basic set of services by the eScience Center. And we defined the desired functionalities of the first prototype, which again will be due in a year's time. And we started the implementation of this first prototype. So this is now a work in progress. It will be officially released in March 2023, but we are hoping to provide a sneak peek to you in something like end of the summer. So hopefully by the review meeting, which is the reporting period finishes at the end of September. I suppose that the review will be in probably November. So I suppose by that time there will be some kind of working version of the Science Center, which you can try and which we can also show on the review meeting. So this slide again you have seen previously in my January presentation. And this is our kind of current understanding of what services will be provided by the eScience Center. So starting from the lowest level, we are going to provide basic kind of security and user management services, which are going to provide for authentication, and generally user account management. We agreed that the eScience Center will be open. But even an open service requires certain user rights and user privileges. Open, for example, doesn't mean that anybody can publish without knowing who that person is. For example, new data collections or new models that would not be desired, obviously, because then anybody in the world can publish any kind of malicious software. So we need to then know who these model owners are, who these data collection owners are, and that is very important that we have these user management services. And then on top of that, we have the higher level services. Some of them are related to like community building, which will be very similar to a kind of website or a portal, which will have news, blogs, collaboration functionalities, and so on. Then we will have e-learning services, which are going to support users to learn about the eScience Center itself, but also about the science as well. So for example, get access to publications, user manuals, tutorials, videos, webinars, and so on. And then finally, we will have the most important part of the eScience Center, which is the scientific services. So this is going to provide access to data collections and models, some of them through cloud-based services, and also everything which is required to operate such a service. So providing help desk, ticketing system, and so on for users. Because if we provide access to services, then users will have problems, and then the problems need to be supported and helped. So this is what is the kind of very, very, very long-term big vision of the eScience Center. Not everything will be part of the first prototype, but some of this will be part of the first prototype. I'm going to explain exactly what, and then you will see how it is going to evolve during the next 4 years, actually, which we have left from the about 3 years, which we have left from the end of until the end of the project. So, what do we want to achieve first? What will be the kind of essence of this first prototype? So, what we want is that we want to enable you to register a data collection or a model with the eScience Center. And this is very important because obviously that would allow us to have these resources, data collections and models in one place, all accessible through the eScience Center. But in order to register these data collections, we need metadata that describes the scientific meaning and properties of these data collections and models. And that is what is going to be described with a kind of modified version or simplified version of the ESPAS ontology. And after my presentation, Ivan is going to present that and going to explain how he, rather, because it was more or less his big work, we just helped a little bit in that, modified the ESPAS ontology and the ESPAS metadata structure to describe PITHIA resources. So this is going to be performed by data collection and model owners. Those people who are owning these data collection and models, they need to describe their models with this ESPAS metadata, and then they need to register these in the eScience Center. The second functionality is to search for data collections and models using scientific terms and keywords. This search is performed by the scientific user, okay? So this means that the user can go to the eScience Center, put in various search terms using the ontology, using the ESPAS ontology, and find the right data collection or the right model. For example, I put a probably stupid example here, searching for a data collection where observed property is inner heliosphere, whatever, yes? From my interpretation, whatever, from your interpretation, obviously, the scientific meaning, what you are actually looking for. So the eScience Center will allow you to define these search terms by clicking boxes. And then based on these search terms, the eScience Center is going to return you the data collection and the model. And once it is returned, then you will be allowed to interact with the data collection and the model by retrieving the necessary data from the data collection, executing the model to get the desired result or perform, and all of this will be performed by the scientific user. Yeah? So you will be directed to this data collection and model, and then you can interact with this data collection and model. Now, the question is that what kind of mechanisms we are going to provide you in order to execute these models, and what will be the way, and not necessarily immediately, but by the end of the project, what will be the ways how you can execute models from the eScience Center. And for that one, we have 3 ways in mind, which we are going to support for model execution. All of this, obviously, after the user found the right model, using that metadata search, which I mentioned in the previous slide. So we have in mind 3 model execution mechanisms. The one is that execute the model on the PITHIA site or node that provides, okay? So go to the PITHIA site or node and execute the model there. And this means that we are not going to execute anything in the eScience Center. Everything will be executed on the PITHIA site. We just provide access to that model which is running on the remote site, which is running on the PITHIA node from the eScience Center. And to achieve this, we are considering 2 options. And I'm going to discuss these 2 options in much more detail in my second presentation, after Ivan's presentation. And these 2 options are, one is providing a user interface, which is what we call a statically built web form. But what it means to you is that this will be practically the user interface of the model as provided by the module provider. Okay, so we are not going to do anything. We either going to direct you to the remote site and say there is a user interface there and execute your module there, or we are going to embed that with some clever technology into the eScience Center, but still the user will believe that they are in the actual remote site. Okay, so you are going to see exactly what the PITHIA site or node is providing as a user interface. We are not changing that user interface, which is very nice, but that will mean that every module will look a different way. Okay, because that is the way how it is provided. Again, don't worry about it. I will going to come back to this in the afternoon with much more details. And the second way is to create some kind of web form dynamically in the eScience Center, which will be standardized and which will look more or less the same for every module. And then the module will be accessed by an API, which the module provider needs to develop. Again, details are coming in the afternoon. The second way is that the module can be executed in the EGI cloud. And this will mean that the eScience Center magically will deploy and execute the module on EGI cloud computing resources. So the user just presses a button, and then that button will have the magic happen. Okay, and everything is magically, and I'm going to show this magic later, everything will be deployed and will be executable. So this means actually creating a copy of the module, deploying it in the cloud, and enabling the user to execute this private copy with this magic. And once the user finished the execution, then the copy is killed, so because we don't need that anymore, and the resources which are used for that copy will be free. And when the user needs to execute the model again, then again a copy will be created, and then the user can use it again. Okay, but we are not keep it running all the time, only when somebody actually uses that. And then the third way will be is that for some modules, we consider that the user can just simply go to the PITHIA node and can simply download the module and then execute on their local computer. And we originally did not consider this execution mode, but many of you indicated that some modules are already supported in this way. So we thought, yeah, it is very simple. We can also support this from the eScience Center as well. So these are the three ways. And again, more details are coming up in my second presentation. So question is, what have we done so far? How far we got with this? So first of all, we tried executing a real PITHIA model in the EGI cloud, which was option 2 in this previous slide. Yes, this one. And this one we succeeded. So we took an exact PITHIA model and we executed it on EGI cloud computing resources. This is what we call a proof of concept. And this is what we submitted as the deliverable of our proof of concept. We used some cutting edge technologies which our group developed in previous European projects to make this magic happening. And we also published this as a scientific publication. So this was quite an interesting experiment, even from the computational, from the computer science point of view. And we published the paper in Concurrency and Computation in collaboration with NOAA, describing how this magic can actually happen for scientific applications. And I'm going to tell a little bit more about this, but not about the technical part. So that's probably relevant for you. I'm just more going to concentrate on what is the magic which is happening. So as I said, everything is magic, and you don't need to understand what is really happening in the background. So this was the first thing which we do. And then the second thing which we have done is that we started designing and implementing the first real prototype of the eScience Center. So the proof of concept was only trying out technologies, but this is not something which you can use. But now we started developing the real first prototype. As I said, that the official release of this one is March 2023, and probably a sneak peek will be available by the end of the summer. At least this is our current plan. And the focus is on publication and search for data collections and models. So with this sneak peek, with this first prototype, you will be able to publish and search for a data collection or a model. And this will be nothing fancy, just find a data collection or model using scientific terms, using the terms of the ontology, and then return a URL where you can interact with that model. So forget about everything more complicated execution. We just give you a URL, and then we say, go there, and the model is there, or the data collection is there. That will be the first prototype. Now, let me talk about this first thing, this EGI execution which we have done. And this was the first bullet on this slide. So how did we execute a model on EGI cloud computing resources? What was this proof of concept? So first of all, what model did we execute? And this is where I'm completely lost, and I need to admit it to you. So if anybody would like to correct me, I'm very much welcome. So we took a model which was, I was a little bit confused, to be honest. Probably I'm still a little bit confused. What is the difference? So I believe that this is the same model. Maybe, I don't know. So if somebody from NOAA would like to correct me, I'm keeping quiet for a second, and I'm giving them the opportunity. But we had this model which was called storm time ionospheric model, or topside solar wind driven autoregressive model for ionospheric short-term forecast. And when I even want to be more lost, then I kind of listed what this model is doing. So it is doing solar wind driven empirical, it is a solar wind driven empirical model for the middle latitude ionosphere storm time response. It forecasts ionospheric storm effects at middle latitudes triggered by solar wind disturbances. It uses near real-time data sets describing the solar wind conditions in the Earth's vindicity. It homogenizes and resamples data at a standard temporal resolution. It analyzes temporal variations, detects intervals of ionospheric storms, and stores the relevant data in appropriate relational database schema. So I assume that you do understand what it is doing, which I do not, I have to admit, okay? But from my point of view, obviously the important thing is to show NOAA that, yeah, we can deploy this, you can execute this, and once we did it for you, then you can actually use it, okay? So then we just handed it over, and we said, okay, try it and see whether it is still producing the same results which you were expecting. So this was the model which we have taken. And then how did we do the magic, or what did we actually do, is that we deployed this STEAM model. So currently the STEAM model is deployed on the internal DIAS platform, which is running in NOAA. So this means that access at the moment is restricted to local users. So only people in NOAA can access this model. The installation of this one is quite complicated and time consuming. So they cannot really say other scientists, take it, go away, install it for yourself, and then you can run the model for yourself. Because it is very, very complex to install this model elsewhere, okay? May face a lot of difficulties, may not be a kind of straightforward and so on. What we achieved with our magic is that we can deploy this model by practically one click of a button. So instead of taking this and telling system administrators, best of luck, try to put it on your computational infrastructures, we created a solution where a user, a simple user, can click a button and then the magic happens, and then this one is up and running in some cloud infrastructure, and nobody needs to worry about how it was installed or how it was made available. So how did we do it? What needed to be done by NOAA in order to make this with us together, obviously, to make it possible? So first, this model needed to be put into what we call a container, okay? So think like a shipping container. It's a little bit more sophisticated than that. It is a computational container called Docker. So we need to put this solution inside a container And this is a little bit of computer science work. But nowadays, this is a pretty standard computer science work. So we can help in doing this, but many of your developers, I believe, also understand what it means putting an application inside the Docker container. So we needed to put this model inside the Docker container. And after that one, we needed to describe this model in a language which is called Tosca, and we needed to explain how this application works. Okay, and this is again requires a bit expertise from our side. We needed to create this description. Again, in the afternoon, I'm going to explain that even this part we can provide in a magical way, where it will be created automatically later on. And once this description was created, then we applied our magic, which is called Mikado. And with this Mikado magic, we could deploy it by one click in any kind of cloud resource. In this case, we used EGI, but we can deploy it in Amazon, in Azure, wherever you would like to run your application. Okay, so this is practically what we did with this application, that we took the NOAA application, we did a little bit of re-engineering of this one, but once it was done, then now everybody, without worrying about Docker and Mikado, can just press a button and then the application is magically up and running. So obviously magic is complicated, yes? So what is behind the magic is something like this. And now I don't want to explain this to you, yeah? Because it is not relevant to you. What is important is this will be completely hidden from your point of view, yeah? So all this magic is not actually visible. It is all magic, and what is behind the magic is not visible, yeah? You don't know how the magician is creating its magic. And that's the whole beauty of this, that you are not worried about that. So you will never see this. You will never be exposed to this complexity, which I'm showing in this slide. The magic is just going to happen and everything will be hidden completely. And that is this small part of the magic when you create this description, but this will only be relevant for the developer. So that person who actually is the developer of your model, that person needs to do it once. But again, we can provide even help in that, like creating some kind of magical tools which create this, which create these kind of descriptions and the Docker containers for the developer. So most of this will be completely hidden. And what the end user is going to see, hopefully the happy end user, is that they click a button, the application starts, they can use that application, and then they can be happily get away with the results. And once the application finished, then they can just kind of kill the application because they don't need that anymore, at least not for a while. So what the user will actually get is just see the results. So this is some sample output from the Steam model, which was generated by actually that component which we deployed in the cloud. So what the user said, obviously we had some discussions with the NOAA team after the experiment, and what they said was positive from their point of view, is that now the model, which was previously deployed in NOAA, and only people in NOAA could execute it, this is now available for on-demand execution. So if any other user would like to use it, they need to press a button, then the application deploys, they can get a copy of the application, and then they can run it. So this means that they can deploy this model by one click and then set custom parameters of the application and run the application with the custom parameters. It is now potentially available outside NOAA, so anybody can do this deployment. We also added a Jupyter Hub, a Jupyter Console, and the Jupyter Notebook interface in front of the application. Previously, this application did not have any user interface. It was only accessible through the command line. So it did not change that much, but with this Jupyter Console and Jupyter Notebook, at least this is a little bit more user-friendly, and we did not really have to do too many things to achieve that. This is actually a way how we can make data collections and models hosted on heterogeneous and non-interoperable infrastructures available to a wider research and science community. Okay, so we can and now make this STEAM application available for people outside NOAA and on different types of computing infrastructures. And also, as I said, with this Jupyter console, Jupyter notebook capability, we provided more advanced user interfaces for this. So what we have done so far, so this was one part of this, and this is what I explained in this first bullet point. So we tried executing this STEAM model on the EGI resources. And I also mentioned that we started designing and implementing the first prototype of the eScience Center, okay? And this is what I would like to explain in the final part of my presentation. So we started designing and implementing this first prototype, which focuses on publication and search for data collections and models. So what the first prototype is doing is that nothing fancy, you can publish your data collection and model, and then you can find the data collection using scientific terms of the ontology, and then we return you a URL where the user can interact with the model or where the user can interact with the data collection. So this will be the first prototype. And what we did in this is very simple. So this prototype, as I said, will enable registration and search for data collections. So what we enabled in this first prototype is two main functionalities. One is the registration of the model or the registration of the dataset. So this will mean on your side, on the data owners or the model owner's side, is to prepare the necessary metadata in a standard format, which utilizes this SPAS metadata structure and the SPAS ontology, which uses ISO 19156 on observations and measures. But this has been specifically enhanced for space physics and specifically simplified for PITHIA. And then we are going to support the registration process where this XML document can be uploaded to the eScience Center, and then you can just put this into a kind of storage which is included within the eScience Center. I mean the metadata document. The actual data and the actual model will stay in the site where it is accessible or where it can be executed. And this is the part which will be provided in much more detail in Ivan's presentation regarding the ontology and the metadata development, okay? So this preparation of the model, how you can prepare the model metadata, what kind of metadata needs to be prepared, Ivan is going to present right after my presentation. We already prepared sample metadata for 3 models and data sets, and he is going to explain that in full detail. And once it is done, then the second functionality is to provide something like this, you can see on this screen, where you can tick boxes, and once you tick the boxes what kind of models or data sets you are looking for, then the eScience Center is going to return you the result of that search, and we're going to send you a set of links that if you visit these data sets or models, those are fulfilling those particular functionalities that you are looking for. So what we did so far is that we compared various technologies, how this eScience framework can be implemented. We assessed their feasibility for the purpose of the Science Center, and we were assessing and comparing these technologies, both front-end development technologies and database technologies, which we are going to use for the development of the eScience Center. And we selected 2 major technologies. One is the so-called Django framework, which is a Python-based web development framework for the development of the web interface of the eScience Center, and we also selected the database technology where the metadata will be stored behind the eScience Center. But again, this is kind of less relevant to you. This is just to assure that, yes, we did this technology search and we have kind of decided on the technologies which we are going to use for the implementation. And what could be a little bit more interesting is that we started this first prototype implementation where now with the selected technologies, Django and MongoDB, we created a web user interface where the user can publish the model and where the user can search for a model. And these screenshots are from this very, very, very first prototype, which we have implemented. So this is just a sample screen from the model registration phase. The model registration includes uploading your pre-prepared XML files to the eScience Center. So you just go to a file browser, then you upload your XML files, which are describing your model. And once you uploaded it, then we are going to check the syntax of this. So we are putting it through an XML validation phase. Then it checks, okay, are your XML files correct? Or have you made any mistake in that? And if you made a mistake, then we return an error message. Or if they are passing this parsing process, then everything seems to be okay. So then you can continue the registration process. And once the registration is complete, then you will be returned with the search screen where you are searching, for example, by observed properties. So you tick certain boxes. And once you tick the boxes, then you press the search button. And after pressing the search button, you will be returned with the results of your search with a description and also an online URL where you can access that particular data collection. So this will be the first prototype. Okay, from your point of view, these are the three main functionalities. Owners of data collections and models can publish their data collections and models, and ordinary end users can search for data collections and models and will be returned with the result of that search, and then will be directed to a link at the moment outside the eScience Center to access that data collection or model. So with this one, I'm finishing my presentation here, and I'm very happy to answer any questions. Excellent. And I'm stopping sharing my screen to see.
Thank you, Tamas, for the very clear presentation. We can take some questions now.
Yeah, this is Jürgen speaking. I have one question. If a data collection or a model is registered and after some time you find that you should maybe change the keywords or the description, so is it easy to access it again and change things? Or
yes, of course, we need to provide functionality for updating it. I assume that will be that the model owner needs to register, then the model owner needs to log into the eScience Center and then press on a button which says update model. And then we can agree how this can be done, either uploading a new XML file, for example, or later on maybe providing some more sophisticated functionality. At the moment in the first prototype, I imagine that will be you uploading a new XML file, a modified XML.
Okay, thank you, Tamas. Clear.